Hi, I'm Ed Amoroso, and I'm here with John Dawson, who's the president of ExactData. And I want to welcome John to our studio.
Thanks, Ed.
How you doing, man?
Good, good.
It's good to have you here. I want to learn all about ExactData, ExactData.net.
Yes. Yep.
And what you guys, what got you into the business?
We were, I was actually at Kodak at the time, Eastman Kodak. I was having a great time there, great company. Really treated me well, but we were working some neat technologies in the document imaging space, and we came up with this idea about doing similar things for data processing applications that we're doing in the imaging space, and thought it was really super cool. There were a lot of applications for it, and the environment at Kodak at the time wasn't something where we'd be able to get funding or try to get that commercialized. At the time, in the early 2000s, they were, downsizing, and it was just a tough financial situation. So we ended up, I was in a position where I could get funding to bridge funding because of my position in the company, and we went out and started up a company and haven't looked back since.
So many great companies start that way, right?
Yeah.
Where there's like a parent, big firm, people meet, they have ideas, it's not the right environment, they go off and great things happen. It's happening all the time. That's exciting. That's exciting. Were you up in Rochester at the time?
Yeah, Rochester, New York. Yeah, moved there to work for Kodak, and then bounced around a little bit, but met my wife there, so we live there now, stay there now.
Now, tell us about ExactData. It's a synthetic data generation. How do you describe sort of the what of the company when you're getting into it?
Sure. So it's high fidelity synthetic data generation. By that I mean it's very rich. It mirrors the production databases, longitudinally consistent, very realistic. But it's actually
from top to bottom, like things you see, and probably the data representation similar.
Internally consistent, consistent across disparate data stores, across your system of databases. Wow. But it's actually designed for the system under test. So we'll take the system requirements, algorithm requirements, and we'll design the use cases and requirements into the data. Lots of coverage of the use cases, lots of variation of the use cases, and actually not only generate the data to test it, but the system response file, so you can actually do black box testing. You can run the data through, compare it to the what we say it should be, and do your scoring and actually measure precision of the system.
Do you think of it as more art, science, or kind of both? Because it seems like there'd be a nice artistic component to that.
Yeah.
Right? Does that make sense?
Interesting question, yeah. I'm an engineer. I love the science behind this. It's hard science. It's unveiling the vein behind what goes on in these systems. A lot of the clients we work with don't know how these systems are performing, which is kind of scary to me. And we're actually able to unveil that veil and quantitatively in a very systemic and quantitative fashion. A lot of good math behind it. Tell them exactly what's happening, and to me that's really exciting.
But you must have to curate a little bit. Like, this is not like you're running a mimeograph machine where you just churn the stuff out. You probably have to get in there, and I'll bet you have clients that have some weird looking data, maybe irregularities in the data that have to be, am I getting that right? I'm imagining a big chunk of it being automated with an expert curating to make sure it's perfect. Am I thinking about that right? Or?
Yeah, it's, of course the data is very complex, and we're not subject matter experts in these things. Like in cyber applications, we need cyber experts in.
Well, you'd have people coming from who knows where.
Sure.
It could be biomedical, it could be financial, whatever, right?
Electronic medical records, we use clinicians, and they actually help us understand what the data characteristics should look like, what diabetes progression would look like as an example. And we write that into our data models, and that gives it the realism in the data. And then we can actually write in the very specific use cases as we create this haystack of good data. Then if we're doing a clinical decision support tool for medical applications, as an example, we can write those into the data models and then generate lots and lots of variation and lots of data that has that characteristics.
Now, when we met and we first started talking about what you guys do, obviously it's in the context of cybersecurity. You think that's going to be a big application area for you guys?
Yeah, I do. We just really started looking hard at this in the last year or so, less than a year. And what we're finding is that there's some really great, in my mind, some great use cases. As an example, deception technologies is creating that really rich cheese
Right. Honey pots.
Exactly. As an example, performance testing, the rich content, payload content. From what we've been able to tell is really not part of a lot of the performance testing that's being done today. So when you actually run those systems in the production system, it really doesn't show the performance that it really should, that it did in a lab environment. Another example, machine learning, AI, training those is another great example. Just pure training of analysts for different cyber use cases.
Have you had people come and say they want to do some kind of training and build us 10 million examples to train the heuristics on what a cat looks like or what a malware looks like for AI?
For AI?
Learning, yeah.
We have not done any AI. We've had some, for non-cyber, we've had some exposure to some Intel AI applications about how to train them, and it's a real problem. I mean, you need a lot of data.
Absolutely.
And then you need a lot of variations around that data, and that's something that this technology does very well. I remember the example we're using was who shot John F. Kennedy, and the answer was Oswald, and then you had to train these AI systems on all the variations around that, and it gets very, very complex. Jack Kennedy, misspellings, character missing, and things like that. And we can do that very, very quickly, create millions and millions of records that have the question and the system response, and be able to train these systems very, very quickly.
I'm going to guess a lot of people watching who are mulling over in their minds how they train their AI systems to get better. I mean, there's still a lot of systems that require that curation, human assisted. I never find a problem with that. Sometimes vendors apologize for that. I think it's not a problem. It seems perfectly fine in a lot of cases. You guys are like the absolute perfect solution for that. It's really good because you're not. Here's another thing that I thought. I know we talked about this before. Hackers are really clever, and when you throw up data in a deceptive environment, and it's different in even a little subtle way, they pick that up quickly, and the honeypot is worthless. So again, the idea to have that high fidelity top to bottom is really powerful. I think you guys are sitting on some interesting opportunities here.
Yeah, no, we do too.
Yeah, this is good stuff. Good stuff. So company, you're where are you guys headquartered? How are you set up?
Rochester, New York.
Rochester.
Most of our business is U.S. federal, so we travel to D.C. almost on a weekly basis.
How do you get from Rochester to Washington? Is there a shuttle?
We do fly, but we drive a lot. It's a 6-hour drive. It's not bad. So get a lot of work done in the car.
That's good. That's good. So the whole team's up there?
Yes. Well, we have one person down in the D.C. area, but for the most part, we're up in Rochester.
With the D.C., are those the federal applications more on the defense side, civilian, or maybe both? You've probably done both.
They're almost all civil to date. We have done some Intel apps, which is pretty exciting. We'd like to get into the DoD, which is
probably had some little DARPA work that you may have
we did. We have done work for the DoD too. But we would really like to get out of the federal marketplace and get into commercial applications. There's a
lot of commercial organizations that would like to get into federal.
Yeah, it's the decision-making process in the federal doesn't always have to do with ROIs and what's best for the company or for the what's going on there. So
this is probably a naive question, but if you got a call from like a Japanese firm, is it easy to do Japanese language? Is that a special art to go to other languages?
No, that's a great question. If it's English or Romantic, I'm sorry, I forget the word, but if it's with English characters, we can normalize it fairly easily. We've done projects where it was Persian languages for Iraq, Iran, for countries that spoke those languages.
Those are hard languages.
Well, it was English based, English
Yeah,
character based,
yeah.
but it was just localized so that the names made sense, for an Iranian, and an address made sense for an Iranian location, et cetera, et cetera. But Chinese characters or Japanese characters is something that I don't think we could do. I haven't even thought about it. Yeah.
Have you ever had a customer talk to you about doing sort of a streaming of data, where you're streaming something,
Sure.
like instead of like, here's your file, go do it,
Yeah.
but rather become a source? How would that work?
Yeah, so it's service virtualization. It's where you would tag the data with request response pairs and work with a service virtualization tool like CA Lisa.
Yeah.
And then you'd feed into that, and then you could hit the system and tag it in such a way as you're actually hitting the system, like it would look like data would be hitting the system in a virtualized environment.
Yeah.
Like DHS runs, airline information comes in on the Trusted Traveler system, and it's billions of records, and it spikes, the way that works. And to really test those systems, you've got to be able to mimic that, and we'd use techniques like that to be able to do that.
That's so interesting. I bet volume is probably also a dimension that comes up. I know in my world,
Yep.
when we deal with denial of service attacks, we're all terrified that we're going to see these 1 terabit per second kind of barrages on gateways. And there've been, I know there's some synthetic generation, but it always struck me as kind of primitive.
Yeah.
You know, a lot of the things that I've seen in my career, primitive. I'm guessing you guys can really turbocharge the heck out of that stuff. Make
Yeah.
it really look like a nation state coming after you with some stuff, right?
Yeah, yeah. I don't believe there's any theoretical limits to the size of the data. I mean, there's practical limits, obviously.
It's probably whatever you can generate.
Yeah, with server sizing and length of time and things like that.
That is so interesting.
Yeah, I mean, even attack type cyber applications where we would flood a financial services application with realistic data they wouldn't be able to tell was synthetic until they started to try to process it, would be another example of offensive type application.
I would think like NSA would want to take your stuff, have you generate records, encrypt them,
Yeah.
and they could practice cryptanalytic tools, maybe in the open
Sure.
with something like that, because it's not real data.
Right.
So you could have hackathons and other types of things in
Yeah.
the cryptanalytic community with complete safety. No problem to because a lot of times when you do cryptanalysis, you gotta be a little careful if you're doing it on real stuff because you expose PII and so on. You got to be perfect at that.
Yeah. They call it challenges.
Yeah.
So where we'll generate the data with specific characteristics that would have a challenge that they're trying to solve, whatever that might be. And because it's fully synthetic, they can release it out to the industry community integrators, and then have them actually solve that problem and prove that they solved the problem. And then it really shortens their purchasing cycles because they know exactly what that they're procuring actually works. So it's really a smart way to go about doing some of those procurements.
So I have a prediction. I think in a couple of years, cyber is going to be your biggest application. That'd be my guess.
Yeah, we're pretty excited.
Spectacular.
It's a neat use case. We think we bring a lot of value in this very, very niche area where we are the market leader in this particular area, and we are seeing a need for it in some of the people we've talked to. So, we'll see. Yeah.
Love the company. I love all the stuff you do, and I love that you guys are in Rochester. That's such a cool tech community. Rochester Institute of Technology has such a rich tradition of engineers, and obviously Kodak, having such deep roots in that community. It's cool that you guys are parked there. There are a lot of tech companies around you. I would imagine there would be.
Yeah, it's interesting. You've got U of R, you've got some major universities, RIT.
Yeah.
You've had major corporations like Kodak and Xerox that have downsized, and people like the area. So we have a very, very rich talent community. We have some of the best engineers in the world, available out there for us to hire and recruit. So we've been really lucky with the talent we have. It's just world class.
Looks like you're having fun. You like being the
Yeah,
president
absolutely.
of the company?
It's a great place to be.
And your wife's involved too, right?
Yeah, a little
So
bit,
cool.
a little bit, but it's a good place to be. We kind of went through a lot of the hard times any startup does. You know, everybody goes through it, and we're getting some recognition. We're working on some of the largest IT projects in the world today in the federal government, and we're a key technology component for these projects. And for a small upstate New York company, I mean, to me, that's just really, it's really exciting.
One other thing, a parenthetical thing, my observation, you guys are engineers. Like, you guys are about as much an engineering culture as I've ever seen. Like, you probably don't spend 3 seconds on marketing, and you've done well, with your team, really just on the basis of building great tools.
Yeah.
Now we got to get you like this big marketing engine.
It's pretty sad, or it's pretty sad that we don't do that very well.
That's all right.
But,
you know something? For what you do,
yeah.
I see a lot of the inverse. I see a lot of companies that'll swing through that don't have that engineering culture. You know, at a market, it's sort of vacuous.
Yeah.
You guys are literally the inverse of that. Really cool tech, great opportunities, and I'm so happy that things are going well. I'm excited for the company. I have a feeling you guys are going to be a big monster group pretty soon.
Hope so.
You come back and see us, remember us, way back
The
when.
little guys, right?
Yeah, there you go. Be nice to me on your way up, right?
Right.
So that's awesome. Listen, thanks so much for
thank
coming
you.
to visit us in New York, and good luck with all the things you're doing, and hopefully you'll come back and visit.
All right, great. Thank you.
Awesome. And we will see you next time.